Quite often, it's convenient and useful to think about the distance between some number x and the number 0 on the number line. Sometimes when you're working with a variable, say x, it's convenient to think about how far that variable is from 0 on the number line. That is, it can be convenient to think about the distance between the number x and 0 on the number line. Now, there are several ways that we can describe this sentence. I can do it symbolically by writing this, and I read that as the absolute value of x. All right, so here's how I read this. Read this like this. So I read this as the absolute value of x, and what it means is exactly this. So when you see this, that just is a shortcut way of saying all this. I see this, I read this as the absolute value of x, and it means the distance between that number x right inside there and 0 on the number line. Now I can also describe this sentence here with a picture. I can do it visually. Here's a number line, I'll label it x, I'll put 0 on the number line, and now x is some number, maybe it's here, and I can represent this sentence just by this drawing right here. That represents what? That's the distance between that number x and 0 on the number line. So when I solve equations or inequalities that involve absolute values, I'm going to do two things every time. I'm going to write this. Now it slows me down a little bit and takes some time, but at least I'm pointing to the right answer. I'm going to write this, then I'm going to draw the picture, and that will produce the appropriate equation or inequality. So when I see something like this right here, the absolute value of x, what's going to pop into my head is this. The distance between the number, now I'm going to leave that blank here because this is going to be like a template. I'm going to write this every time, and whatever number or whatever expression I see in here, I'm going to write right here. So the distance between the number, whatever I see in here, and 0 on the number line, that's how I'm going to interpret this. Now I'll show you a little example here. Here's an example. Let's suppose that we have an equation like this one here. Say we have 3x plus 4 equals 19. So as soon as I see this, I'm going to write this template, and that's going to produce an equation for me. So just read this as a sentence now. What does it say? Well, on the left side, it says this. It says the distance between the number, now what's inside here? That represents the number. In our case, this number is 3x plus 4, so it represents the number 3x plus 4 and 0 on the number line. So when you read this part right here, the left side, here's what it says. The distance between, BTW for between, the distance between the number that I see inside here and 0 on the number line, now keep going, equals, so is, and then what? What does it say here? 19. Okay, so I'm just going to say 19 units. So when I come across an equation or inequality, I'm going to translate it from symbols to English. And I can just write it like this because I know what that left side means. It always means this. The distance between the number, whatever I see inside here, and 0 on the number line, and then I'll finish it off, is, in this case, 19 units. Now draw a picture. Here's 0. Number line is x. Now, where is this number here? Where is this number? Well, according to our sentence, that number, 3x plus 4, is where? It's 19 units away from 0. Now, that 19 units could be out here to the right. So if I could go out to the right 19 units, and if I go out 19 units, I'm out here at 19. So I'm saying then that 3x plus 4 could be here. All right, so that's at 19, but it's also that 3x plus 4, so that 3x plus 4 could be right there, right? If I drop that 3x plus 4 down, it would be 19 units away from 0 on the number line. It's like I'm doing this. I reach in here, I pick up that 3x plus 4, and I start at 0, and where do I go? I go 19 units away, and I drop it down. But now I could have gone 19 units in the other direction, right? We could have gone over this way. I could have gone this way 19 units. So if I drop it down there, where are we? Right? If I go 19 units this way, I'm at the number negative 19 because I'm to the left. And now if I drop that 3x plus 4 here, I'm saying that that 3x plus 4 is the same as that point negative 19, and I'm still 19 units away from 0. Now look, this gives us two equations here. What do you know about that 3x plus 4 here? Well, it's the same as negative 19. So you get 3x plus 4 is negative 19. And then what do you know about this 3x plus 4 over here? Well, it's positive 19. So you get 3x plus 4 equals positive 19. And now we can solve both these equations. Subtract 4, so we'll get 3x equals, what do we get here? Negative 23. Divide x equals negative 23 over 3. And over here, subtract 4. We'll get 3x equals 15. X is equal to 5. So now I've got the solution to my equation. It's x equals negative 23. X could be negative 23 over 3, or it could be 5. So I'm able to do this because it all comes back to this. When I see absolute value, I think this. The distance between the number, whatever I see in here, and 0 on the number line, in this case, is 19 units. So I write that. Then I draw a picture, and from the picture pops out my two equations. And I'm able to solve those.